Alrighty, so since there was no class today due to the great and amazing amounts of snow, house I just barely covering the roads. But hey, who knows what it is like in other areas. But due to all the snow, we're not having class today, so I wanted to do a video so that we can do essentially an online class. So hopefully you can follow along and handle this as far as our quote unquote in class exercises, and then we'll be able to continue on Thursday with where we left off. All right, so last week where we left off, we had just created this location. Let's see, here we are logged in as just in case. We created an IT385 directory, and we used git and all the git commands in order to create that as a repository. Inside of IT385, we also created a directory called Python. And then inside of Python, we created a file called hello world, which we can run by doing a /hello world. Oh, I guess I need to change it into Python. And then /hello world. And we'll see that it actually reports back whatever was the hello world command. So there we go. So that was our very first Python script. A couple of things to note here. We have the shebang up here up at the very top. We have a function, in this case, a function called main, and it is doing whatever is inside the function defined by white space. So this white space in front of the print command says it's part of the main function. And then lastly, down here we have this if __name __. That's basically saying if this command is being called directly for a main service, then go ahead and run the main function. And you'll see this in a lot of Python scripts, and we'll eventually get to the point to where this can do one thing if we're called the script directly, or another thing if we don't. So, before we continue on with that, there is one other step I wanted to take, and I'm actually going to go up one directory. So I'm now in the home just in case IT385 directory, and I wanted to create a script. There's the word. I wanted to create a script to help me with my GitHub publishing. Basically, what it is we've been doing some git commands. We've been doing a git add, we've been doing a git commit, and then git push. And we've been doing it over and over. And that's 3 different lines that we have to type. And that's way more than I want to type. So I want to create one command that does all that for me. So I'm going to vi, and let's call this publish git. Publish git.sh. So this is going to be a bash script, not a Python script, but it's going to be useful for everything we're doing later. So even though it's not Python, I think it's still useful. So it takes us into vi. Again, down at the very bottom, it says, hey, here's a brand new file. We want to start this off by going into insert mode. So we hit the letter I on our keyboard, go insert, and we start off with the shebang. Now, because this is a bash script, the shebang is /bin/bash. So # exclamation /bin/bash. That is our shebang. Let's put in a little comment here. Script to publish changes to GitHub. Just so we know what it is. So in this script, I want to call essentially 4 commands. Very first one is a git pull. If there are any changes on GitHub, I want to download those to my computer. And that's what the git pull does, is it pulls down the changes to me locally. Normally, 99% of the time, that's going to be saying, hey, there's no changes. But that's fine. Next one, git add dot. I just want to add all the folders in my directory. There may be reasons why I don't want to add all of them, but for this script, I just want to say add everything. Next, I want to do a git commit -m and then a $star inside the quotes. $star means take a comment from the command line. We'll see how that works when we finish this script. And then lastly, git push. So there we go. Git pull, git add, git commit, git push. Now we're still in insert mode. We want to get out of that, so I hit escape. Insert mode goes away. I then hit :WQ for write quit and hit enter. Last thing we need to do is make this file executable. So chmod +x publish git. There we go. At this point, we can just run this publish git script. So /publish git. And I want to add a comment. Remember that weird $star? This is where I can add my publishing comment. So add, let's see, let's actually put this in quotes. Added publish script. And then I hit enter. And it runs all 4 of those commands. First thing it did was it did a poll. And it says, yep, already up to date. No polls necessary. It then did the git add, and it says, yeah, okay, I went ahead and I added, oh, not sure why it said 2 changes, but it added publish git.sh. It then did the git commit with this right here as the comment. And then lastly, it did the git push. One of these, I think this right here is the git push. So at this point, now if I look into GitHub, and I sign in, there's my publish git, and it has the comment of added the publish script. It's interesting. What else added? Huh, apparently my hello world got updated. Interesting. Updated? Changed? Apparently I never published it? I'm not sure. Okay. So there we go. That was the command. So cat publish git. Again, when I ran the publish git, I added this in the quotes afterward. What that did in the script was translated it to this. So that allows me to have my my commit command with a comment. So now I just run one command called publish git, and it pushes everything out to GitHub. Yay! All right. So with that being said, let's continue on. So back into Python. So let's change back into our Python directory. No. CD Python. Let me actually out. So we finished off with our hello world, our very first script. Let's actually talk about variables. Let's start off by talking about variables. Python has a lot of different types of variables, and I'm actually going to go into interpretive mode. Python 3, just to give a quick little run through of variables. So variables can be strings. So for instance, I could do a message equals hello there. There we go. The great thing about Python is the fact that I didn't have to specify what type of variable message was. Some scripting languages, you have to actually say, oh, this is a string, this is an integer, this is a float, this is a double. In this case, I just have to say message equals, and it automatically identifies it as being a string. Same thing, I can do n equals 17, so n for number equals 17. I could do another one called pi, so pi equals 3.1. Unlock. Pi equals 3.141596. And at this point, I can pretty much do whatever I want with these variables, as you would expect. So I could do a print message, print n, even print n plus pi. There we go. or an n minus pi. Yeah, I didn't actually need the print. Yeah. So with that, like I said, there's different types of variables, and in order to find out what these are, we can actually use the type command. So if I do type and I say message, then it returns back and says, oh, this is a type of str or string. Okay, so since it's a type of string, that means I can't necessarily add to it. So if I tried to do, for instance, print message plus pi, I should actually get an error message here. Yes. And the reason for that is because message is a type of string, but if I do a type of pi, it's going to say that this is a type of float. You can't add a number to a word, right? That's like the whole questions. If the wind is blowing from the south and there's a bird on the west side of your tree, then how much is the cost of a tree in the number of purples? It just makes no sense. Yeah. So the main types that we're going to be using is the float, the string, and then with n, it is a type of integer. Basically, the difference between a float and an integer. An integer is a full number, such as the number 7, or the number 42, or the number, 1, however big that is. An integer is a whole number. It's not a partial number. A float, however, is a partial number. So it could be like 0.00001, or it could be 1 billion.1. These are all floats. Basically, if there's a decimal point, it's considered a float. You can add integers and you can add floats. Kind of the interesting thing is you can actually convert these back and forth. So for instance, right now I have a float called pi. I can actually convert this to an int by just saying int parentheses pi. And then it returns back the integer portion of pi, which just happens to be 3. I could do the same thing with our number. N is, 17? Right? Yeah. I could do the same thing with our number, except do it the other way around. I could say float n, and watch, this will change 17 to a 17.0. Now, from a math standpoint, there's absolutely no difference between 17 and 17.0, but from a computer standpoint, they're two different types. So there you go. That's something to note. By the way, up here when I did the print message pi, I could actually make that work. Do an up arrow. What I would have to do is I would have to change pi from a float into a string, and I can do that with the command str, or with the function str. So what I'm doing here is I'm changing pi into a string, the same way as I changed n into a float and pi into an integer. Here I can change pi into a string, and then I hit enter, and what happens is in this case, the plus does not add, it simply appends the string 3.1415926 to the end of the string hello there. So the plus sign can be sometimes add, sometimes append. I know, it gets crazy. All right, so let's get out of that. That's the interactive mode. Just went into interactive mode in order to show these specifics. So in order to exit out of this, 2 options. I can either type exit with parentheses as a command, or I can hit the keys Control D on my keyboard. So Control D as in dog. All right. So now that we've talked about variables, let's talk about local variables. Let's actually create a script. It's called local variables.py. Again, I for insert mode, and we'll start off with our shebang /bin /python3, and a comment here, local variables. Local variables. So in Python, there is something referred to as scope, and the scope that a variable works in. Let's actually get this written up. Let's see, let's start off with a function called foo. And inside of foo, let's do a equals 5, and then print a. And then we'll call the command foo, call the function foo, and then print a. All right, so quick run through of what this means. So here we've created a function. So when we run this script, we don't necessarily do anything with the function, but we learn about it. What the function does, basically when we run it, we create a variable called a, and we assign the value 5 to it. All right, piece of cake. At that point, we then print that out to the screen. Awesome. Let's see, so that's the function. Otherwise, when we're running the script, we run through, we call the foo function, and then as soon as that foo function is done, as soon as it's assigned the value and printed a, we then print the value a again. Let's actually run this before we talk about what's happening. I'm currently in insert mode. I hit escape to exit insert mode, :WQ, chmod +x, local variable, tab complete helps out, really helpful. And then go ahead and run local variables. And we see that we start off, it spits out the number 5 and then gives us an error specifically saying a is not defined. Well, hold on a minute. Let's look at that. Let's look at that local variable script here. So we start off and we call foo, and we actually assign a the value 5. And we print that out, and we can actually see that was right here in our output, right up there, that we actually had the number 5. It was assigned. We were golden. We then try to print the value of a again, and it says, nope, can't do that. That variable is not defined. And what this is showing us is the idea of what's called a local variable. Inside this function foo, we created a variable called a. Outside of that function, the variable a has never been created. There is no reference to the letter a or variable a. There's no assignment of value to the variable a. It only exists within the scope of this function. This is called a local variable because it exists only locally inside this function. The second we left the function, as soon as this call ended, we then try to reference it, and it doesn't exist anymore because it was a local variable that only existed locally inside the function. Hopefully that kind of makes sense. There's also what's called a global variable, which we'll be getting to shortly. All right, so that was local variables. Let's then talk about changing variables. So let's do another one. Oh, actually, before I go on to the next one, I want to actually save my my changes. So let's see, // all right, so let's really quick, pwd, print working directory. I want to save my changes to GitHub, right? Rule of thumb, whenever you commit something to GitHub, whenever you commit a change, you want your comment to not have the word and in it. So I don't want to do two things. All right, so I'm currently in the Python directory. My script to save things to GitHub is in the IT385 directory. So in order to call that script, I need to do .. for the parent directory, / and then, oh geez, what did I call that? What did I call that? Publish git. Okay, so / publish git, and my comment is created local variables. There we go. So I committed my change, and perfect. All right. So as you saw there, again, this is a Linux thing. I did an ls ... That showed me the parent directory. Showed me the contents of the parent directory. I then do a ... / publish git. So parent directory has publish git. So ... / publish git. Hopefully that makes sense. All right, so let's clear that. Next thing I want to do, talk about changing variables. So let's do another script by changing variables .py. Go ahead and insert this, do our shebang. And let's, I don't know, comment, changing variables. It's really bad comment, but we'll go with it. So we'll start off with the variable called x, and we'll make it say hi. By the way, single quote, double quote, doesn't really matter. Probably just be consistent. Next thing I want to do is create a couple of functions. Let's see, def read for x. And in this function, let's go ahead and call print x. And then define change underscore local x. X equals I. Yeah. X. And then we'll just call read underscore x. And local x. And finally print x. All right, so what we've done is we've started off and we've created a variable called x, and we've assigned the value hi to it. So when we run this script, the very first thing that's going to happen as we start from the top down, it's going to say, hey, I'm going to create a variable called x. I'm going to assign the value hi to it. All right. We've then created a function called readx, which will just simply print out the value of x. Another function called change local x, which will assign the value by to x and then print out the value. And then finally, when we get down to the very end, we're going to call readx. So in theory, we should print out the value of x. We'll then call change local x, which would change the value and print it out. And then finally print out whatever x is at this point. So let's go ahead and save this, mark it as executable, and run and see what happens. Change variables, and then / changing variables, and run it. All right, so we see our results here are hi, bye, and then hi again. Let's look at what our command was to see exactly how that worked. So as we're starting off with the script again, here we start off and we start with the variable called x. And then we keep going down. We're not really doing anything here yet. So we start off with x equals hi. We then say read x, which says, hey, go ahead and print the value of x. This is actually called a global variable. Because we assigned x up here, up at the very root, we didn't assign it in any subfolders or any subroutines or any functions. That is actually what's referred to as a global variable. So when we call this function readx, it actually prints out this value right here. Awesome. So it read the global value and it printed it out. Okay, so that's what this call did right here. The next one, change local x. We call it up here and we say x equals by. So we've changed the value of x, but we're within a function. So we're only changing the value of x within the scope of this function. The scope. So at this point, what we're doing is we're assigning x a local value. Up here, we still have a global value of hi. Here, we're setting a local value of by. That's like somebody, there's always slang that's going on. And so people will be like, oh man, that's bad. And so for most people, the word bad is not good. But in some cases, you want to be counterculture, and the word bad means something good, like, oh man, that's a bad hairdo, or I know I'm showing my gray hair here. Bad can mean something locally that's completely different than bad meaning globally. So here we have something locally meaning something completely different than globally. So we assign a local value to x. We print it out. That was our by up here. And then we finally called the final print command, which then goes back to the global value of hi. So that gives us our hi by hi. Yeah. So local values, global values, there's a difference. And even though the variable name is the same, they can mean two different things. All right. So I want to go into another script where let's actually update this script. Before I want to update this script and actually do some changes to it. But before I do that, I want to save this. So / publish Python, publish Git. That will publish my commands. Everything up to date. Did I already save that? Oh, empty commit message. I didn't add. Okay, I didn't add a commit message. So created changing variables. There we go. I thought something looked wrong. I didn't add a commit message, and therefore it didn't commit. All right, so that was changing a local variable instead of a global variable. Well, now let's go ahead and see about changing that global variable. I'll look at my notes here and make sure I'm doing the right thing here. All right, let's go back in and edit that file. I'm just up arrowing until I get to the vi command. I could have retyped it. It's not that hard. Okay, so what I'm going to do is I'm going to use the arrow keys to move down here to the end of my change local, and then I hit I to go back into insert mode. And at this point, I'm going to hit enter to enter some spaces, and I'm going to add a new function called def change underscore global underscore x. So here we're creating a function that will change the global value. And in order to do this, we specifically have to call out global x. Here, x now equals adios. I think aloha. Aloha means goodbye and hello, right? So, yeah. And then we'll print x. And then we'll come down here at the very end. After our original print x command, we will then do a change global x, and then finally read underscore x. So what we did was we just simply added in this new change global. The global x basically says, hey, this local x, the x that I'm working on in this function, I want this to be the global x. Don't do just like I did up here with the local x and create a local one. I want to actually work with the global x. We then assign a new value to it and print it out. All right, so at that point, we assigned a value to x and we printed it out. The only real difference between the two functions is that command right there. We then call readx again, which should just simply print out the value of x. Let's go ahead and run this and see what happens. So escape :wq and then / changing variables and enter. Just like before, it starts off with hi by hi because the local and global variables did change. We then called the change global x and we printed out the very first aloha inside the function. We then called readx, which returned the original hi, and now it returns aloha. So this this command right here, global x, when we assigned, what that means is when we assigned a value to x, it actually overwrote x equals high globally. So that means I can work with x both locally as well as globally. It's all up to me. It all depends on what I want it to do. All right. So with that being said, let's go ahead and save that, publish, and my command is updated. Sorry, my comment, updated global var. Actually, not updated. Added global function. There we go. The reason why these comments are helpful, let's actually look back here. If I look back in my command here, I can see, oh yes, I added a global function. If I look into my changing variables here, I can actually see a history. And I can see the very first comment created the script. And then my very next comment added the global function. So I can actually tell by the comment kind of what happened, what changes. All right. With that being said, now let's talk about arrays. So an array, hopefully you've gone through and you've done your homework. I haven't had a chance to grade them yet. I'll be doing that as soon as I'm done with this video. But hopefully you've gone through and you've looked at your at the idea of arrays. So let's go ahead and do yeah. Let's go ahead and create a script. Just call it arrays.py. Start off with the shebang, as always. Demonstrates using arrays in Python. And we'll start off with a variable called myArray, because I'm really suck at naming things. Oh, actually, I missed a step. What I need to do in order to work with arrays. So Python and a lot of different scripting and programming languages, they have a subset of functions that work, or features that work in automatically. Others can be loaded up. So imagine like you're working on a household project and you need that special screwdriver. So what you have to do is you have to go out to your toolbox and you have to go find that one special screwdriver. That's kind of the idea of what we need to do here in order to work with arrays, is we need to add that one special tool. What we're going to do is we're going to import the array tool. Kind of what we're doing. Yeah, essentially what we're doing here. So in order to work with arrays, we have to import arrays. My array equals array. Let's call this I. And then 1, 2, 3, 4, 5. So here we've created an array and we've assigned the values 1, 2, 3, 4, 5. At this point, we can go ahead and we can start printing things about it. We can start looking at the array itself. Now, in order to look at a specific item in the array, what we do is we use a square bracket and then the index number of the item we want to look at. In this case, I want to look at index number 0. Now, index number 0, remember with computers, everything starts counting 0. So when I say print my array 0, it should hopefully return back the number 1. Let's do a couple more print commands here, and then we'll look at the results. Let's see, my underscore array 2, print my underscore array -1, and then just simply print my array. All right, so I'm going to go ahead and save this. And let's go and just mark this as executable and run it. And let's look at the results. We can see here we get the numbers 1, 3, 5, and then this weird string coming out here. Let's go ahead and look at that script again while we're looking at the results to see exactly what it means. Very first print command said print my arrays index number 0. Remember, we always start counting at 0, so that means that it should be returning the number 1, which we get right there. We then say return index number 2. So if this is 0, that's 1. This is 2. We should have returned the number 3. And we see right there, we did in fact return the number 3. Awesome. One of the cool things about arrays is they can work not just forward, but backwards. Here we say print my array -1. Well, if this is 0 and this is 1, then that means we need to go the other way. So this right here would be -1. And as we can see from the results, yes, 5 was returned. So if we need to return the very last item in an array, we just say -1. That actually comes in extremely helpful. The alternative is trying to figure out how many numbers are in the array and then calling, the specific index number for the very last one. And then lastly, we just said print my array, which returns back the entire array, which is exactly like what we typed right there. So what can arrays be used for? Well, an array essentially is just a list. An array allows me to have a list of items. Here there are numbers. It could actually be, let's say, tasks. So the very first task may be do the dishes. The second task may be sweep the floor. The third task may be vacuum. The fourth task may be mow the lawn, something like that. So we could actually type in strings in here. And then I would just simply have a list or an array of chores to do throughout the house. All right, so let's go ahead and save this one. Let's see, created my arrays. Created arrays. Yep. Go ahead and publish that. And then let's go ahead and make a few more changes to that. I'm going to go back in. And what I'm going to do down here at the very end is just add in some new lines. So the letter I to go back into insert mode, enter. I'm going to work with this array a little bit. So what I'm going to do is I'm going to do a myArray.append. And here I'm going to put the number 99. Now, if I was to ask you, what does the command append do? You're probably going to say, it might add it to the end of the array. And you're probably right. But we'll actually run it and find out. Also, at the same time, I'm going to do a myArray.insert. And in this case, 0, 0. And then lastly, say print my array. And I'm going to make it a little bit different. I'm going to say to list, parentheses, and then finally close parentheses. So I just added these 3 lines down here at the very end. Let's go ahead and run that. So escape :WQ and then /arrays. And we will see now that we have this 0, 1, 2, 3, 4, 5, 99. So first thing we did was we did a myArray.append 99, and you probably thought to yourself at the time, append would simply append to the end of the array. It would just simply add on to the end of the array the number 99, and you were absolutely correct. The second command we did was an insert, myArray.insert 0, 0. What this is, it looks like an owl. All right, what this means is in space number 0, in slot number 0 of the array, insert the value 0. That's where that 0 came from. Is essentially 1 was 0, we pushed it to the right. We pushed 1 up to slot number 1, and then in slot number 0, we inserted the number 0. Let's see, if I remember correctly, this is the position right here, and then this is the value. I could be backwards. I would have to actually confirm that. And then lastly, we did a print myArray.toList. So instead of seeing this whole array I, comma, blah, 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 we just see the list or the values right there. So the toList function cleaned it up a little bit for us. All right. So with that being said, very last thing before I save this. Let's see, didn't updated arrays. Added, append, and insert arrays. Got to be descriptive in our comments. All right, and then very last one before I let you go is talking about two-dimensional arrays. So if I array2d.py, go ahead and add in our shebang. And add in a comment, working with 2D arrays. Now, two-dimensional arrays in its very simplest form, I like to think of these as a checkerboard. Checker or chessboard. Let's see. Checkerboard. Sure, there we go. So what we have here, if we look at the very first column or very first row here going from left to right, this very first row could be viewed as a single array. This very first black square would be position 0, and then the next one position 1, 2, 3, 4, 5, 6, and 7. That could be viewed as a standard array, a one-dimensional array. The two-dimensional array essentially allows me to have more than one row. It allows me to have these other rows right here. Probably the easiest way to think of it is if one row here is a single array, then I'm having a second array full of rows. It is an array of arrays. One array is left to right, the other array is top to bottom. Hopefully that did not confuse you more than otherwise. Well, let's try it out. Let's see. So array 2D equals, add spaces around the equal sign just to make it pretty. Now previously with arrays, we'd put everything in these brackets, for instance 1, 2, 3, and that was one simple array. That was a one-dimensional array. For a two-dimensional array, what we do is we put those brackets inside of brackets. And then I can do another one, 4, 5, 6. And then another one, 7, 8, 9. And there we go. So very briefly, what we have here is we have an array embedded inside of another array. We actually have 3 arrays. First array, second array, third array, all embedded inside of an array. So it's an array of arrays. Yeah. So we can print the whole thing. And that's probably going to be pretty anticlimactic when you look at it. Or we can print one of the arrays. Let's see, let's do number 1. Or we can print one specific section, one specific component of the arrays altogether. Let's see, let's do 2, nope, correction, like that. Let's go ahead and save this. Mark it as executable. And then run it. All right, so the results we got back, the very first thing we did was we called a print array 2D, and we get this whole list right here. Kind of anticlimactic. You probably expected that you would see something similar to that, because here we assign to array 2D this. And so when we printed it out, we got that. Okay, that kind of makes sense. The next line we said print array 2D square bracket 1 closing square bracket. Remember, everything starts at 0, so our very first item in this array of arrays is this. So that would be 0. The next one would be this, which would be 1, and that is exactly what got returned. The very third line, we said print array 2D 2 and then 2 with square brackets. So that's saying in the array, see, this is 0, that's 1, and then this is 2, and then inside of this array, we have 0, 1, and 2, and as we see right here, we actually returned the number 9. So we were able to do an array of arrays. So there we go. That's our very first brief primer into working with strings and variables and numbers and arrays. These are items that we will be using quite extensively throughout the class. Hopefully none of this was really new to you. The use of arrays may be somewhat new to you. Maybe. But we are going to be using them quite extensively in the future. Let's see. So with that being said, on Thursday, we'll continue on and we'll actually start talking about logic loops and functions and all kinds of great things with that. So have a great day, enjoy the snow, and I'll see you then.